Okay, in this video we have we're supposed to be using an algebraic representation. That's where you see the x and y in a parentheses, and I'm going to change it to 1/2 x, 1/2 y. Alright, we're supposed to explain the effects of a given positive rational scale factor. And the 1/2 in this situation is the scale factor applied to a two-dimensional figure. We have a triangle here on a coordinate plane with the origin as the center of dilation. Okay, so what we're going to do here is that we're looking at the algebraic representation, and I'm going to highlight that. That's this guy right here, or this right here. Alright, so that is the algebraic representation. What this means is that the original is x and y. The prime is going to be half of that, according to this. Now, I just want to kind of point out something here. This here, the number that's in front of the x, that's my scale factor. And it's telling me what I'm going to multiply the scale factor. That is telling me what I'm going to multiply each of these by. Alright, so what I'm going to do here is I have a graph here, and I'm just going to ask a simple question. If you got to remember this, because you know the other test on this. When your scale factor is greater than 1, what happens to your shape? When it's greater than 1, what should happen? It should get bigger. When your scale factor is less than 1, what happens to your shape? It gets smaller. And I've said this before, think of money. If you have $10 and you multiply it with the number greater than 1, which is 3, 3 times 10 is 30. So see, $10 got bigger, it changed to 30. If you take scale factor less than 1, that we're talking about like 0, like decimal or half, or like fraction. So if it's less than 1, then it's going to be multiplied, and it'll be, let's say half, for example. So what's half of $10? $5. So the point is, it's got to be between 0 and 1. It's like a decimal or fraction. So that's scale factor. It's something really important to know, and it'll help you on any assessment. All right, so here we go. We're going to do A prime, and I'll do this in a blue color so we can kind of see it. So A prime, we're going to take half of 2, and then we're going to take half of 6. So if I do this, I should get half of 2 is 1, and half of 6 is 3, so I should go up 1, 3, and put a dot there. So that'll be my A prime. So my A prime is going to turn into 1 and 3. Alright, now my B prime, so I'm going to take half of 6 and half of 4. And so when I do this, half of 6 is 3, and half of 4 is 2. So now I'm going to go 3, 2, and put my second dot. This will be my B prime. Alright, and then my C prime, alright, is I'm going to take half of 4 and half of 0. Well, that's easy. So half of 4 is 2, and half of 0 is just still 0. So my C1 is going to equal 2, 0. 2, 0 would be right here. So if I redraw this, there is my new shape. And you can see that we've been multiplying with a scale factor of a half. And so my shape gets smaller, and it does. You can see that the shape here gets smaller than the red one. So algebra representation can be good because you could have a whole number there like 3 or 4, and it can make the shape bigger. You could have You can do it with number less than it, it can be smaller. Now, we are later going to talk about what happens if you add or subtract to the x and y in the algebraic representation, which is going to make a thing, which makes the shape translate.